Hello, everybody, and welcome to today's California Coastal Resilience webinar. I'm Carrie Boyle, a Sea Grant Fellow with the State Coastal Conservancy, and I'll be facilitating today's webinar. Just a few housekeeping items before we begin. We'll have discussion time at the end to answer any questions that you might have throughout the presentation, so please feel free to type your questions into the questions box in your webinar window. And Charles might answer them as he goes, and he'll definitely have time at the very end to answer them. So be sure to get those in towards the end. The webinar today will be recorded and made available on the Coastal Conservancy's YouTube page, and a link to that will be sent out in a follow-up email. So today we are joined by Charles S. Colgan from the Middlebury Institute of International Studies at Monterey, or MIST. He is Director of Research at the Center for the Blue Economy at MIST and is also Editor-in-Chief of the Journal of Ocean and Coastal Economics and an Adjunct Professor of International Environmental Policy. Today he'll talk about his recently completed study on regional economic vulnerability to sea level rise in San Diego County, and you can download a PDF of that report under the handout section of your webinar control panel. So with that, I will hand it off to him. Take it away, Charles.
Thanks, Carrie, and good afternoon to everyone, wherever you are, spread out across California. I'm in Maine. But today our focus will be on San Diego. So people have seen a lot of different studies on the question of vulnerability to sea level rise. There are all kinds of studies out there that have been done over the past 10 years. And the topics that people have looked at, when they look at economic issues, they generally tended to look at two issues. One is vulnerability of infrastructure, including things like roads and power plants and wastewater treatment plants and so on. And the other is vulnerability of property, usually is measured with property tax data, and a particular focus on residential properties. Many of you will have seen the report that was released just a couple of days ago from the Union of Concerned Scientists, where they did a national study on residential property vulnerability. And there's actually a whole set of data that you can download on residential property. We looked at a different question, which has really kind of been the missing issue in a lot of the discussion about sea level rise planning, and that is, what does sea level rise mean for the local economy? What does it mean for the jobs, the industries, and the output of goods and services from the local economy? The project that we undertook was with the San Diego Regional Climate Collaborative, which wanted to begin to explore that issue. And the way in which we went about this was to basically do what most of the studies have done in one way or another, is to define vulnerability as the location of economic activity or the location of vulnerable assets relative to estimated flooding. Most of the studies have done some version of that. The difference in this study is that we're specifically looking at data with respect to employment, output, and so on. We do not, as I'll talk about at the end, include in vulnerability, in our definition of vulnerability, the adaptive capacity, which is kind of a modifying variable to the whole vulnerability and issue. So this is kind of a gross vulnerability study designed essentially to encourage communities to look in detail at where we are estimating the vulnerability to be, and to begin to look at what is the current adaptive capacity if the estimates of flooding and sea level rise are relative to the location of economic activity are correct. We use two measures of economic activity. One is we look at establishment level data. An establishment is simply a place of business. It's any place that operates generally all commercial activities, restaurants, hotels, whatever it is. We look at specific establishments at specific geographic locations. We also looked at property values, as many other studies have done, but we focused on the commercial and industrial valuation as opposed to the total valuation in the communities in San Diego County. We looked at 10 cities in San Diego County, and there's a little bit of county land in there, but almost all of the coastline of San Diego County is within a city boundary. For our estimates of flooding, we use the USGS Coastal Storm Modeling System, or COSMOS, with which I'm sure many of you are familiar. The advantages of the COSMOS model are pretty significant for this kind of study. Not only does it include estimates of the extent of sea level rise, which in this case we looked at 0, 1, and 2 meters of sea level rise. Not only does it include the effects of sea level rise, but it also includes the effect of storm intensity, so that you get a combination of both the additional hazard created by sea level rise and the hazard of storm intensity. Storm intensity in this case is measured by the 1-year and the 100-year storm. That is the storm that has a high probability of occurring every year, near 100% happening every year, and a 100-year storm, which is about a 1% probability of occurring every year. And so when we talk about the 1-year storm and the 100-year storm, we're really talking about different levels of storm intensity, and that's where the COSMOS model is very useful, and much more useful than many of the sea level rise models that have been put out, which are so-called bathtub models that simply look at the question of how water will rise in the bathtub, if you will, without taking into effect the weather. So this is the an overview of San Diego County, roughly from the border to the border with Mexico to the border with Orange County. The red and yellow dots represent establishments that overlapped the 100-year and 1 meter sea level rise in yellow, and the red dots represent the 100-year storm and 2 meters of sea level rise. And you can see this a little more clearly in this slide, which focuses in on the San Diego airport area. Each of the green dots represents establishments that we identified relative to the 100-year storm and the to 1 meter of sea level rise and 2 meters. And you can see that we can identify storm establishments that are within the floodplain under each of those scenarios, and those that are outside of it. We actually examined a fairly large number of establishments and then overlaid the floodplains with that. So this is the basic measure that we're looking at, is what do each of those dots represent. The data that we used, which is data we purchased from a company called Info USA, represents employment and estimated gross sales. We added to that the estimates of contribution to gross domestic product, or the total value of goods and services in the San Diego metropolitan economy, which is basically San Diego County. Now, as I said, the COSMOS is very important because of its ability to combine storm intensity and sea level rise, but it's also very important because it measures at each location an estimated depth of flooding. So here you see in yellow and red the storm effects kind of laterally, but you can also see that from the vertical bars, which are not buildings, those are not skyscrapers on Coronado Island. That's a visual representation of the depth estimated by the Cosmos model at that place. That's important because deeper floods cause more damage. The basic relationship between damage and flooding is not just the aerial extent, it's the depth of the flooding and its effects. And so you can see that, in fact, the depth of flooding varies considerably throughout the county. And we're just looking here at the southern San Diego, the San Diego City, Coronado, Imperial Beach area, because it's easier to see this at the tighter scale. And if you think back to this slide up here, you'll notice that almost all of the vulnerable establishments are down in the San Diego, La Jolla area. Once you start getting out of that, there are vulnerable establishments in Oceanside, Carlsbad, Del Mar, and so on, but they're much smaller. And so the real concentration is down here in the San Diego City area. We use two sea level rise scenarios. Well, really three scenarios: no sea level rise and storms as they are forecast. 1 meter or about 39 inches, and 2 meters or about 74 inches. This shows the two vertical lines here show our 100 centimeter or 1 meter line and our 200 centimeter, 2 meter line. Versus the various scenarios that have been used in planning by the various cities in San Diego County. As you can see, our upper estimate of the 200 centimeter line is consistent with a couple of the cities and a little bit above what others have used. Our 100 centimeter line is generally above what people have been using in terms of their scenarios, high, medium, and low. And so we've been a little bit more pessimistic than the cities in our mid scenario, but we're pretty much right on with most of the cities in our upper or worst case scenario, and we are pretty consistent with the most recent state guidance on scenario planning. This is these two graphs show the mean and maximum depths. They basically pick up on the vertical, the skyscraper graph I showed you a couple of minutes ago. For each of the 1 year and the 100-year storm scenarios with sea level rises of 0, 100, and 200 centimeters. We're going to use centimeters and meters more or less interchangeably here. So when you see 100, that's 100 centimeters or 1 meter. 200 is 200 centimeters or 2 meters. 0 is 0 in both calculations. You can see the mean depth. This is the average depth across the Cosmos generated floodplain for each of the scenarios. And you can see the maximum depth, which is quite significant. For example, in the 100-year storm, in the 1 year storm, 200, a 2 meter sea level rise is almost the same as the 100-year storm, the 100-year storm with no sea level rise, both at about 91 inches. So the difference between the storm intensity and sea level rise has this relationship of, obviously it gets more serious as you go up in terms of the scenarios, but what's interesting is that once you get to the 100-year storm, even with low levels of sea level rise, it's about the same as the 1-year storm with the high level of sea level rise. The one on the right is a histogram of the distribution of establishments by the Cosmos scenario. Now, there's a different histogram for every scenario. What I've shown you here is the 100 or 1 meter sea level rise, 100-year storm with 2 meters of sea level rise. It just, as you can imagine, at the extremes, the numbers are more visible. So you can kind of see how there's a substantial variation, approximating a normal curve, not exactly a normal curve, but there is a substantial distribution across the area, across the exposed establishments in terms of the depth that they are, a depth of flooding that they face. And that's why, again, Cosmos is significant, and why, as I'll show you in a minute, we have to make some adjustments for the depth of flooding estimated at each particular establishment. This graph is pretty unintelligible. It's more illustrative. I'll show you what it means in actual terms in a minute. Basically, what you see here is in green, the size of the circle represents the distribution of employment employment size in each establishment. And as you can see, most of the establishments are pretty small in terms of the number of employees. The largest group is from 21 to 3,850, and that reflects that there are a lot of small businesses that are being affected. It's not just the larger businesses, though as a proportion of the employment affected, obviously the larger businesses take on a greater share there. You can also see the significant concentration of vulnerabilities in Coronado, along the entire shoreline of San Diego and up into the Mission Bay area. So there's little of the shoreline region of San Diego, southern San Diego County, that is not fairly vulnerable under one or other of the scenarios that we examined. So here are the basic numbers by employment by each of the scenarios. The 100-year storm is on the top 3 bars, the 1-year storm on the bottom 3 bars. And you'll notice that there are two estimates for each of the scenarios. The first one, we'll just look at the top line for a minute here. The first one, if you look at the blue bar, it's 49,700. That's the depth unadjusted estimate of employees that are in establishments in the floodplain estimated by the Cosmos 100-year storm 2 meter sea level rise scenario. Now, not everybody is going to be uniformly affected by the flood, and that's kind of critical. So we do what's called a depth adjustment. I won't explain the algorithm in detail, it's in the report. Basically what we did was to weight the employment in each establishment by its distribution into the 1st to the 10th decile of flood depth. So basically those establishments that had the least flooding depth were weighted less than the employment in those establishments that had the most flood depth. And that's how we came up with the 6731 number, which is the depth adjusted figure. Now, this is, to be honest, this is a somewhat made up number. There's no, in the real world, there is no 1/10 of a flooded employee. You're either flooded or you're not. But when looked at the aggregate, because of that histogram I showed you earlier, we have to take account for the variance in flood deaths across the region. And so we try to do that in the aggregate by doing this depth adjustment process. As you can see, the numbers for the 1-year storm and the 0 sea level rise, pretty trivial. You can see that the numbers increase with the intensity of the storm. I want to point out a particular, I want to make a point because I'm going to come back to this in a little bit when I talk about conclusions. The tendency in these sea level rise studies is to kind of look at the worst case scenario, and that is to look at the 100-year storm, 2-meter sea level rise. Well, for illustrative purposes, there are a lot of reasons to do that, and to be perfectly honest, the 100-year storm and because the 100-year storm will almost certainly become the 50-year storm, or even more frequent with climate change. And 2 meters of sea level rise is increasingly viewed as more likely than it has been thought of in the past. There are good reasons to think about that. But the really interesting stuff is the 1-year storm, the storm that's almost certainly going to occur every year. And notice how the vulnerability to the employment vulnerabilities here to the 2-meter and 1-meter sea level rise, even in the relatively likely scenario of 1 meter of sea level rise, you still have nearly 1,000 employees in the depth adjustment and over 7,600 employees at risk in the unadjusted scenarios. And that, I want you to remember, is every year that that number of employees and that could be affected. If we look here, this is in annual sales volume. The Info USA data that we use imputes sales to each of the establishments. And you can see that we're talking about $1 billion in annual sales from a 1-year storm and 1 meter of sea level rise. Depth adjusted, it's about $57 million. Over $8 billion in the depth unadjusted worst case scenario. But even adjusting for depth is still over $1 billion in annual sales being affected. Now, one of the things that has to be noted here, however, is that floods don't last the whole year. We hope they don't, at least. We hope that they are relatively short-lived, but flooding can take, as we know from experience in places like Houston, Louisiana, and other places that have been hit by hurricanes. Sometimes you can have businesses that are out of business for 6 months, a year, even longer. Most of the flooding events in California don't result in that long a period of destruction, but we don't know how long they will be. They could be 5 days, it could be 1 day, it could be 5 days, it could be 6 months. So one of the things we did in the study is to estimate a daily sales vulnerability. So this figure shows the depth and depth adjusted and unadjusted losses of sales from the affected establishments. We then basically said, you, based on your own estimate of how long flooding and flooding damages might take businesses basically offline, you can kind of estimate what a 30-day flood would be or a 5-day flood would be, because we've given you the basic unit here of daily flooding sales losses. Employment's we do estimate the daily employment as well, but employment is a little dicier because in short-term flood events, It's not uncommon for employees to be kept on the books. They don't lose their jobs. But in many industries, if the place of business shuts down, if you've got, for example, mostly hourly employees, they're not going to be paid, and so the effects vary across the industries. This is a picture of the industries affected based on the establishments that we identified. Now, the graph on the left shows the number of industries by scenario. So in the 1-year storm, 0 sea level rise, there are 15 industries affected, up to 46 industries in the 200 centimeter or 2 meter sea level rise. In the 100-year storm, it ranges from 22 to 50 industries. And the average across all scenarios is 16. On the right-hand side, you see the industries in the 100-year storm, 2 meter sea level rise. These are depth unadjusted numbers, and we use this just for illustration purposes. Notice that the top two are accommodation and food service and drinking places. This is primarily in the Mission Bay area. If you add in retail trade, amusements, gambling and recreation services, performing arts and spectator sports, those industries, basically the San Diego tourism and recreation sector is clearly at the head of the list for the job-related vulnerabilities from storms and sea level rise. Other industries, administrative and support services, some of those jobs are jobs related to tourism and recreation, but this is a general catch-all of a variety of industries. And if you look at administrative and support services, along with professional and technical services a little further down, that's over 1,000 jobs. And most of it's probably not surprising, particularly anybody who's been to San Diego, that the tourism and recreation sector would be severely affected. But most people don't think about administrative and support services, professional and technical services, wholesale trade, ambulatory healthcare services as being among the most affected areas by sea level rise. They tend not to be part of the conversation because we're not really measuring it the way we've done it here. And it just shows that there are a whole variety of urban types jobs and urban type industries in San Diego that are potentially going to be affected. One of the things we did was to ask what are some of the most important industries in San Diego. And to do that, we use something called a location quotient or a specialization ratio. Basically, anything to the right of 1 here is more important in the San Diego economy than it is in the California economy. So other transportation equipment manufacturing is the shipyard, NASCO shipbuilding rather. But again, accommodation, professional and technical services, amusements, gambling and recreation, administrative and support services, ambulatory healthcare, real estate, performing arts, etc., food services and drinking places. All of these things that I just showed you on the previous list as being particularly important in the category of vulnerable industries are in fact more important in the San Diego economy than they are in California as a whole. We broke this down by city and scenario. Not surprisingly, San Diego City tops the category. This is San Diego plus La Jolla. Chula Vista is next, followed by Coronado, National City. Imperial Beach shows up in the 100-year scenarios, and so on down the list. We also looked at, as I indicated earlier, commercial and industrial valuation vulnerable to flooding. I'm showing you here the graph of the distribution by city of commercial and industrial valuation that is overlapping with the Cosmos scenarios. And you can see here that, again, San Diego City is going to top the list with Coronado second. Those two together account for 3 of every $4 of commercial and industrial valuation that is vulnerable in the 100-year to 2 meter scenario. But you can see that cities such as Del Mar and Encinitas and Imperial Beach, which don't have a lot of employment necessarily, still have a lot of valuation that is at risk. We went through and took the valuation, the commercial and industrial valuation. We developed a data set on the property tax revenue vulnerabilities from each of the scenarios and from each of the cities. And what you can see here is the result of that. Now, it has to be admitted that this property tax revenue vulnerability is misleading, in the sense that the city of San Diego is not going to lose $15 million in property tax revenues from a flood, unless the land is unless the property on the parcel is completely wiped out and the parcel is returned to essentially vacant land uses. And I should say here that our estimates of commercial and industrial property were just for improvements, not for land. We assumed that land would be unaffected by the flood. This, of course, is somewhat misleading because there are parking lots and all kinds of things on commercial and industrial property that would be severely affected by a flood. But we, for conservative purposes, we left the land alone and only included the valuation of buildings and equipment. But as I was saying, the loss of property revenues is not really going to happen this way unless something gets wiped out entirely. And so this is a little misleading. There will be damages. The damages could affect the property that is, could affect the valuation of the property if it's still in place at the time properties are valued. But if it's all repaired, for example, it's probably not going to have much of an effect at all. We put the revenue number in because a lot of people ask, well, what is the property tax vulnerability from the valuation that we were estimating as vulnerable? So we put the numbers in for each of the cities just so they could see kind of what is the maximum worst case property tax loss from each of the scenarios, and to remind people that there are significant but unknown levels of property tax revenue loss that are possible. We think that we have provided a pretty good and novel picture of the vulnerability in the regional economy of San Diego to the problems of sea level rise and climate change, but we got to be careful about what we were able to do. We looked solely at the extent of the flood and its depth. We did not, as I said earlier, deal with the structures. Obviously, that's a much more complicated problem. If you've got, for example, a building surrounded by parking lots, the flood damage, even from a relatively deep flood, may be attenuated quite a bit. If the first floor of the structure is not a particular, is essentially not a terribly important space. Most of the critical activity happens in second and third stories, then you get a different level of vulnerability. Now, one of the things we learned from Sandy in New York was, however, that much of the damage to commercial properties occurred because almost all of the critical building systems were built either on the first floor or on underground. And they flooded out to a large extent in Manhattan and did a lot more damage than what the models suggested were going to happen. So we are both kind of overestimating and underestimating the possible damages to specific properties because we don't have detailed information on the buildings and the physical layout of the facilities themselves. We used what we call the touch rule, which was if the establishment was a point reference, which was a latitude-longitude reference, was touched by the flood, we put it in the vulnerable category. There is some GIS error built into this, depending on the size of the representation of the establishment and the exact dimensions of the flood as expressed in a shapefile. So there is some ambiguity or fuzziness in that, but the touch rule was the only one that made any sense to us in the absence of much more detailed data. InfoUSA is a data source. It's one of the few data sources, public data sources, I should say, that does contain economic information about establishments at the latitude and longitude level. About half of their data is measured, but about half their data is imputed. That is, it is estimated by InfoUSA based on their own proprietary algorithms to estimate employment and sales. So there is some estimation error in that data set, which we describe in the report in a little bit of detail, but a lot of it, frankly, it's InfoUSA's data, and as I say, they have a proprietary algorithm to it. In our property tax estimates, we use assessed versus market. We use assessed values, not market values. Assessed values of commercial and industrial property are a little more accurate than market values for commercial and industrial, but there is still always a divergence between the assessed value and the market value. The degree of divergence depends upon how often an assessment is updated for each of the properties, how often citywide or countywide revaluations are done. And so there is always a gap between assessed and market values. In this sense, as the property tax valuations that we used are accurate for things like the property tax revenue calculation, but generally understate the market value of the properties that are at risk. We did not do the military, the Navy and Marine Corps facilities. We did not do the Port of San Diego, though. The Port of San Diego is a kind of is an interesting organization in that it owns much of the land in the shoreline of San Diego, the city of San Diego, and surrounding communities. And it actually is the landlord for a lot of different kinds of businesses. Those are included, but we did not look on the cargo and passenger operations of the port, nor did we look at the cargo and passenger operations of the airport. Those are very specific and unique sets of vulnerabilities that really couldn't be done using the methods we used here. Both the port and the airport require separate studies to examine how their disruption from sea level rise and flooding would affect the regional economy. And importantly, we did not take into account growth and change in the economy. We basically compared today's San Diego with tomorrow's storms and sea levels. And this is a fundamental problem in most of these studies. One of the things we tried to do but could not get organized was to incorporate the growth projections from the San Diego Association of Governments, SANDAG, that they would routinely do for infrastructure, particularly transportation planning, into the forecasts. Most of the vulnerability studies, almost all the socioeconomic vulnerabilities that you see, whether of this type on the regional economy or on property values, fail to take into account growth and change. And that's a fairly significant factor throughout all of California. It's a rapidly growing place, and it's tomorrow's San Diego, 2050 San Diego, 2070 San Diego will be different than today's San Diego. We have a limited view of what those changes might be, but even that limited view didn't make it into the study. It's something we really want to do if we do any more of these. So to summarize our major findings, vulnerability measured by establishment locations and property tax assessed values. In our highest risk scenarios, 2 meters of sea level rise with a 100-year storm, we have more than 2,600 establishments with 49,000 jobs, $8 billion in sales, and $6.1 billion in GDP that are vulnerable to flooding. Less than all of those smaller numbers when you do the depth adjustments, $2.2 to $2.6 billion in commercial and industrial structures and equipment valuation. The medium risk scenario, the 1 meter 100-year storm, 830 establishments with 15,000 vulnerable jobs. When we do the depth adjustments, the employment ranges from 900 to 1,600 in the 1 meter sea level rise scenario, and from 4,800 to 6,700 in the 2 meter scenario with 100-year storm. The vulnerability of buildings and equipment, 2.4 to 2.8 billion with annual values of 395 to 451 million once we take into account depth adjustments. I think one of the most important conclusions we came to is this. Flooding is a hazard that disrupts business activity for temporary periods. You know, we think of flooding as essentially wiping out whole areas, and that will eventually happen with enough sea level rise. Essentially, much of the shoreline will become unusable. But long before that happens, the combination of sea level rise and storm-related flooding will comprise a a steady and increasing risk to running a business. It will become more and more, flooding will become more and more common. It will become more and more serious. And so if you look at the daily values of $5 to $20 million in GDP and $62 to $102 million in regional output on a daily basis from the 2-meter sea level rise scenarios, you're talking about very substantial losses occurring on a regular basis. So it's not the flood, it's the floods. The risks to the economy are not the risks of single events, but the cumulative impact of flooding over a long period of time. The reason that that's critical is that essentially the cost of doing business in the locations that are in vulnerable territory will essentially continue to rise until long before the properties or the hotels or the restaurants or anything else, long before those are completely underwater, if that ever happens. The viability of running a business there while continuing to bear the costs of adapting to and recovering from flooding will have made the business essentially unviable. We don't know when that's going to happen. It'll happen at different times for different businesses and different industries. Beachfront locations that need to be at the beach will hang on as long as they can. But for many other types of businesses, so for example, in professional and technical services and in healthcare services, where they don't need to be right at the shoreline, they will eventually face the point where they're going to give up and go somewhere else. Where will they go? Is there space in San Diego for those kinds of businesses to relocate? Given the growth projections in San Diego, or the possibilities of growth, is it possible for those businesses to stay in the regional economy, or will some of them just pack up and leave and go somewhere else? We don't know the answers to those questions, but it's time to begin asking them in some detail. What our study has done, I think, is to raise the raise those kinds of questions and to begin the process of planning for how the economy of San Diego will function over the next 50 plus years with this increasing threat of both flooding and sea level rise. So if you are interested in the study, I think Carrie put it up. The San Diego Climate Collaborative.org will be happy to, that website contains the report and the collaborative's material related to it. Centerfortheblueeconomy.org will take you to our website, where this study, along with another study we just completed on vulnerability in the Mid-Atlantic region, are also available. There's my email address. Happy to answer any questions that we don't take care of today.
Wonderful. Thank you, Charles. So again, please feel free to type in your questions to that question box. And it looks like we have one for you already. So Maya says, thank you for an interesting presentation. And she wonders, how significant are these impacts relative to total sales and employment, et cetera, across the county as a whole? I'm curious if you include those relative numbers in the report.
We did. We described the size of the San Diego economy, which is a very large economy. It's the 10th largest metropolitan area economy in the U.S. and the 3rd largest in California. So in relative numbers, these represent in the single-digit percents of San Diego as a whole. But I don't think that that's I kind of caution against thinking of it that way. because you can kind of minimize the effects. It's clearly the tourism and recreation related jobs are heavily it's a larger share in that set of industries. Professional and technical services, it's not a big share. There are not a lot of that's a very big, and healthcare is mammoth everywhere. So they aren't massive shares of the economy. I think what's more important, however, is to recognize the diversity of industries and to ask the questions about what is going to be the response of the economy to the hazards as they multiply. So it's a good question, but I don't want to overemphasize it. I think there's a tendency to say, well, San Diego is going to lose 2% of its employment, but it'll probably gain more than that from employment growth. That's probably true, but that's 2% of employment that you don't necessarily have to lose if you can figure out adaptive strategies in the meantime.
Great. I'll give folks a few more minutes, or a few more moments, rather, to type in any questions.
So let me just mention that this methodology is transportable in terms of the economic analysis. We do the Cosmos data that we were able to use for the San Diego project is complete. I think for Southern California, basically from Santa Barbara County south, I think that late this year, the USGS will finish Central California. But the idea here can be done elsewhere because we are using pretty standardized data sets. And if you're interested in other approaches to estimating socioeconomic vulnerability, I do recommend you go to our website and look at the report we did for the Mid-Atlantic region, where we looked at relative vulnerabilities across 63 counties, from Montauk Point to Virginia Beach to the head of the Chesapeake, using a whole variety of different measures that was partly related to the kinds of things we did here, but also took a broader picture of the idea of socioeconomic vulnerability.
All right, we have another question for you. Can you explain more about what the tax implications are of flood event damage? That wasn't quite clear. You called the numbers misleading, so what really can we learn from this?
Well, I think there are two things. One is there are property tax implications, and they are potentially pretty large. We can't predict them exactly because we don't know exactly how much damage is going to be done, and we also don't necessarily know how much insurance is going to cover and how that all affects the property valuation. You could look at the estimates that we put together as kind of a really worst case scenario in terms of property tax losses. The important thing, therefore, is not to assume that San Diego City is going to lose X dollars of property tax from floods in the 100-year 1 meter sea level rise scenario in commercial and industrial property. the important point there is recognize that property values are at risk, and the question of how the commercial and industrial structures can be put in place and can be kept operating even during recovery events is one that should be part of the resilience planning in order to avoid permanent losses in the property tax base.
And as a follow-up to that, my question is about the mechanism of how an event could cause that property tax loss. Only if people are wiped out and leave and can't rebuild, or how?
Yeah, generally the property tax loss here assumes that the structure or equipment that is measured here in this vulnerability analysis is eliminated and not rebuilt at that location at the time of the property tax assessment. Now, it might be moved to somewhere else, in which case it might be moved to somewhere else inside the city or to another jurisdiction. But if the equipment and buildings are not functional, don't have the same value on the assessment date, then even if they're in the process of being rebuilt, even if they are intended to be rebuilt, then the property tax assessment can't be done at the pre-flood levels. So a lot depends on the timing here. If you get very severe, long-lived property disruptions, then you could lose those revenues for 1, maybe even 2 years. This has happened in areas affected by hurricanes, where the property tax revenues will decline for a couple of years as properties are being rebuilt. They may recover to earlier levels, but the losses on an annual basis can still happen. And it's a little different story with respect to residential losses, I should say, because residential losses are complicated by Prop 13, and you get a kind of different set of dynamics going depending upon whether or not the properties are rebuilt. But we did look at that in this case.
All right, well, it looks like that's all the questions that you have for now. Thank you, Charles, for sharing your work with us today. And thank you all that are still on the line for joining this webinar this afternoon. Have a great rest of your day.
Thanks a lot, everybody.